very, very competitive proposal that we put together. It provides for $49 million of federal funds and $20 million of cost share from our partners associated with it over the next 3 years. And the idea behind the center is to develop new innovative technologies that can be brought to bear in the algal biofuels industry to make it viable for the future. So those technologies are represented here in a roadmap that goes all the way from the algal system to fuels. And so our center actually tackles all of these areas, including new productions of algae, the modification of algae and cultivation systems such that we can produce more biomass and more lipid, or different types of lipids that can be easily carried to a fuel. New cultivation methods, as I mentioned. This is, for example, a picture of one of our partners' farms out in south of Durango. This is from Solex Biofuels, showing about an acre of ponds. In this case, their system is in a photobioreactor rather than an open pond system, which is also utilized in our consortium. We are developing new harvesting and extraction technologies that will make those systems more efficient, and then obviously taking those lipids into fuel conversion, which is into fuels, transportation fuels, that are the end product. But from a biorefinery standpoint, we want to utilize every component of that cultivation system. So some of the biomass that's produced will go to livestock feed, including mariculture, or direct energy production, or high-value chemicals. And as I mentioned before, it has to be done within a sustainable system that takes into account the utilization of nutrients and carbon dioxide, but also the utilization of water and land, such that we can make it economically viable, environmentally friendly, and energy efficient. The consortium consists of 17 universities, 14 companies, and 2 national laboratories, and the USDA. In fact, Ivan Baxter from USDA ARS is housed here at Danforth. It is also one of our partners. It is a large consortium. It is peppering essentially this production chain from feedstock through harvesting, through fuel conversion and co-products utilization. And we pepper all of this area with all of our partners, obviously much heavier at the front end with our university partners, and much heavier at the back end or the downstream end with our commercial partners. But we're trying to do this from a discovery, development, and deployment perspective. It does require, with so many partners, it does require very, very concise and strict agreements. We do have a very nice memorandum of understanding between all partners, nice multilateral non-disclosure agreement, and more importantly, a very nice intellectual property agreement that helps us understand how we're going to take new technologies, get them introduced through our partners, and actually carry it out into the commercial world. Thank you.
Because of the slides I've seen, I'm going to start the conversation with 2 or 3 questions of my own, and then maybe 4, and then move on to take questions from the audience. As Dr. Danforth said, I'm a retired political scientist, which really means I'm not a scientist, so that scientific questions will have to come from you all to these scientists, and I may just offer the occasional off-the-cuff comment from my non-scientific perspective. Question that occurred to me as I was watching the last slide, and this is a question particularly for you, Jose. I liked the clarity of discovery, development, deployment. What's the timetable? How much time do we have before we really have to have some alternative to carbon fuels, petroleum, and is the discovery, development, deployment timetable, do you have that blocked out by months, by years, by decades, or just whenever it happens?
Yeah, that's a very good question, because I wish I had a crystal ball for you and be able to tell you how much fuel we can produce or any one of our commercial entities will produce within a certain time. We have commercial partners that have a very, very, very quick time around in their roadmap towards commercialization. And they are seeing, some of our commercial partners are already seeing production within their test beds of fuels that are competitive in certain regions of the U.S. I'm sure Dr. Sayer can tell you a little bit about his main partner, FICAL, so I'm not going to steal that thunder, but there are commercial partners today that are saying they can produce fuels between $5 to $10 a gallon. Which is competitive. Now, can they do it in mass? No. We are not seeing anyone right now producing large enough amounts of algal biofuels that can be brought to bear. You are seeing a lot of ethanol being brought into the market, both from cornstarch, some from biomass, cellulosic biomass, and some from sugar cane and other biofuel plants such as camelina. So I think you are seeing the machinery going on. It's going to take some time before we see it take on a large percentage of the overall fuels in the United States. But today we're producing 15 billion gallons a year, 12 billion gallons a year of biomass produced, that's corn, ethanol, and other biomass produced fuels for the United States transportation fuels.
Now, if I were a corn farmer, I probably wouldn't be real enthusiastic about algae. Is that one of the obstacles to commercialization? Does corn have better access in the Congress than scum?
Whoa, those are fighting words.
Yeah, those are fighting words. I hope there's nobody in the audience representing the corn industry. I'm going to get into trouble, or the soy industry. Let me give you a quick story. I just drove up to my daughter's house in Illinois from here, and as I went up, there's several very large fields of soybeans, and right in front of the fields it says soy for energy, and it's in the heart of the food belt for the United States. Okay, both corn and soy are very, very good systems to produce ethanol and other oils for transportation. Unfortunately, they're also taking up part of our food component. So maybe today we're not feeling the pinch, but I think in the future, as our population grows, we are going to feel the pinch for that food in the food markets, and it's going to make a difference. So finding alternatives such as algae or cellulosic biomass is critical to the answer for energy in the future. Dick, you may want to mention something.
I agree.
Okay.
Said
Yeah.
almost off camera. You
Yeah,
agree.
yeah.
You said another slide, Jose, that you had talked about questions of sustainability, but you didn't list them. You didn't make them very clear to me. What are the sustainability issues with regard to algae-based fuels?
With regard to algae, there are a number of sustainability components. For example, just making efficient systems that all the way from the production of biomass itself or lipid production produces enough material that we can take to market in an efficient way, economically efficient way. Extraction systems, for example, if you're familiar with the aquatic species program that was funded by the government for about 17 years, very, very small investment overall for many years, but it was really the start of the algae to fuels type research.